When adding and subtracting radicals, we're going to follow the same rules as we do when we're adding and subtracting variables. So for one thing, you can only add and subtract like terms. So if I have 5x, I can't add it to 6y, there's nothing I can do, I'd be stuck. But if I have 5x plus 6x, now that's something that I can combine, and what we do is we just add those coefficients. So 5 plus 6 would be 11, and then of course the variable does not change, it just stays as x. That's an important piece there. It does not become x squared. The exponent only changes if we're multiplying. If we're adding, we just combine the coefficients. And so that's exactly how we're going to approach it here with these examples. So here I've got two problems that have the exact same number underneath the radical. So these are like terms. So that means my answer is going to have a root 7 in it. And so then I just need to subtract, since it's a subtraction question, the two coefficients. 6 minus 8 is negative 2, so my answer is negative 2 root 7. So again, we're treating it just as if it was a variable. So the root 7 doesn't change, we just add or subtract the coefficients. Now in our second example, we do not have the same number underneath the root symbol. So as of right now, we can't combine these. But what we have to try to do is to see if we can simplify these radicals, so the root 75 and the root 12, to see if maybe we do end up with the same thing once underneath the radical once they've been simplified. So in the case of root 75, we'll start there. So I factor tree that. Again, any of a number of ways I can start. If I can go 25 times 3, probably the easiest. And so right now I can either recognize that 25 is a perfect square, so I can take the square root of it, or if we wanted to, we could factor tree it down to the pair of 5s. Regardless, I'm going to be able to get a 5 out from underneath the radical, so I'm going to have 5 on the outside, but then this 3 is stuck, so I've got the square root of 3 still left. So I've got 5 root 3. Now for the second piece here, I'm going to factor tree the 12 into 4 times 3. So this time I know 4 is a perfect square, so I can take the square root of that. That's going to be 2, but that's going to have to multiply the 3 that is already on the outside. So the second part of my expression is going to be 3 times 2, which is 6, and then once again I have this 3 that is stuck. So root 3 is a part of that second part of the problem. And so now we can see that we've got the same number, root 3 and root 3, underneath the radical, so I can indeed add these two expressions. So I'm going to have a root 3 as part of my answer, and so now I just add the two coefficients in this case. 5 plus 6 gives me 11. So my answer here is 11 root 3. For our third example, it's similar to the previous one in that as of now we don't have the same number underneath the radical, so I can't combine those. But in the case of the 4th root of 32, I am going to be able to factor tree that down and get something out that should make it so that I get a 4th root of 2 to match what's in the second part of the problem. So if we start working on our factor tree here, we can go 16 and 2. The 16 can be broken into 4 and 4, and then the 4s are both 2 times 2. So we can see we've got 1, 2, 3, 4 2s, so there's a set of 4 2s. So that's going to come out of the radical as a single 2, but it's going to have to multiply the 8 that's already on the outside. So 8 times 2 gives us a 16 on the outside, and then we don't want to overlook that we still have this extra 2 that wasn't taken out underneath our root symbol. So we have 16 times the 4th root of 2. And then the second part, there's no simplifying to be done there. It's still 6 times the 4th root of 2. And so now we're ready to go ahead and subtract these. They are like terms. So I've got 4th root of 2 is going to be a part of my answer. And so then I just subtract 16 minus 6 to get 10. So it's 10 times the 4th root of 2. So once again, it doesn't matter if it's higher order roots like the 4th root here or square roots like the first two examples. We can only add and subtract if we have the same number underneath the radical. And then when we do add and subtract the expressions, the number underneath the radical doesn't change. It's only the coefficients that get added and subtracted.